I didn't see you there. My name's Kendall Black. I'm a project developer at Team I-1 Industries. We focus on ideation, problem solving, and the good old design process. Here at I-1 Industries, we specialize in transportation technology. With a multidisciplinary engineering team, we're able to brainstorm smart solutions to complicated, multifaceted issues by engaging in the engineering process. So let's take a quick sneak peek into our workshop, shall we? So let's see what our engineering teams have been cooking up. That's good ideation.
Run, 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 run.
Hi, my name's Cameron, and I'm the mechanical engineer at I-1 Productions, and I'm going to walk you through our design a little bit. Here, we have a variation of the rocker bogie Mars rover. So right here, we have all aluminum members. This is 1/8 inch thick by 1/2 inch aluminum. It is very nuts and boltsy like, so everything is drilled through 1/4 inch holes. This is all drilled together. And the magic with this design is that it's very independent moving. So everything kind of can move separately of each other as it goes over terrain. So a big design challenge that we had when, how can we keep the whole thing from imploding on itself? So what we did is that we enforced springs, 5 springs total. 1 runs straight across. It keeps them to stay close together. And then these 2 right here, we thought of it as that it returns these to a home position. So if this goes too far forward, that spring will pull it back, and the same in the other direction. So when this crawls over hills, those front arms can kind of actuate up and down, and always they won't fall in on the car.
Hi, I'm Kendall Black. I'm the computer scientist here at I-1 Industries. So the challenge for wirelessly controlling a car has a variety of solutions that you can use to approach it. We actually went with Bluetooth just because we don't need a super long range for our car, and also to keep a persistent connection between the client and the car. As you can see in this UML diagram I have created to model the software, the Arduino communicates with a Bluetooth connection object which holds a string address and the status of the connection and has functionality to connect and send and receive data. This is controlled by the graphical user interface with objects for the user to input their desired direction and speed. The graphical user interface is being written in the Python scripting language because it has a very accessible library using GTK to build graphical user interfaces. The challenge here is writing the control app in one language and writing the code for the microcontroller in a completely different language, which is in C++ and Arduino Uno, which our electrical engineer will inform more on later. We have devised a way to send Bluetooth packets to and from the unit, basic strings of text that it doesn't matter what language you're using, they can interpret it. And the car changes its output depending on the Bluetooth packets it receives.
I'm Caden Crawford, the electrical engineer for Team 1, and I was going to talk a little bit about the components I use to make our car. The heart and soul of our car is a 14.8 volt lithium polymer battery that connects to an L298N motor driver. This also steps down our current for our logic, giving us a 5 volt port here, which then comes over and powers our Arduino Uno. Is connected to our motor driver with 4 leads. 2 of them control the left side of the car and 2 of them control the right side of the car. To have different speed settings, you use the PMW pins on the Uno, which can give you out a square wave with varying period lengths. And the longer your period is, the faster your car is going to go, and if you get shorter, quicker pulses, then you can slow your car down.
So let's check in with our chemical engineer, Patrick Hodges.
What are you doing in my swamp?
This is our swamp setup. Right right now the reservoir is filling. The bridge is going to start floating up towards the top. Both our anti-siphon and pump switching mechanism both need a little bit more design work. This is a sump float switch, so you can see that when it floats, our pump actuates, and when it's not floating, our pump shuts off. It isn't siphoning water, but we need to improve the design a little bit. And then you can also see that with both the low flow and high flow pump running, the swamp reservoir still fills slightly, so we need a slightly smaller orifice for our orifice plate head loss section over there. So that'll be the next part of our design work.